Okay guys, let's take a look at our lesson for today. We're looking at derivatives using data, and this is typical of a free response question. What they'll do is they'll give you a prompt and then they'll ask you several questions about the particular prompt. And so that's what we'll be working on today. It's 2 pages of notes, but our prompt is going to be the same on both pages. We're going to kind of go through this, make sure we understand what they're talking about, and then we will work on each of the questions. So, the scenario is that we have water flowing into a tank over a 24-hour period. The amount of water in the tank is modeled by a differentiable function W. Now, we'll stop there for just a moment. That tells us information. Yes, it's a differentiable function, but what does that mean? That means that the function is continuous. I mean, right? If it's differentiable, it has to be continuous. So that really tells us that this function is continuous. So the water flowing into the tank is a continuous flow of water. It doesn't stop and start. So it's a differentiable function between 0 and 24. T is measured in hours, and W at T is measured in gallons. So what we have here is a chart where particular values of W of T have been selected and shown in the table below. So when we have tabular data, when we have data that's in a table, sometimes we are inclined to kind of come up with data that's not there, maybe by averaging or thinking, well, I know that, maybe at 2 it's about this. If they ask us for some kind of a calculation, we certainly could do that, but that's not something that we're going to do without prompting. So what I'm trying to say is you're going to use the numbers that are here, period. Don't make up numbers that are missing. Just use what's here. So the first question says, use the data in the table to find W of 8. Using appropriate units, explain the meaning. All right, so W of 8 equals 221 gallons. And so explain the meaning. It's kind of a format that we can use that would be really helpful to you. We talk about the independent variable first. So we would say at hour 8 or at the 8th hour, however you want to phrase it. That's the independent variable. We just named it. There are 221 gallons of water in the tank. There are 221 gallons of water in the tank. So what's important for us is, first of all, designating our independent variable, naming it with the units. Then we talk about our dependent variable, again, the variable with the units. And then we kind of add in whatever other information that's necessary. Well, it was in a tank or whatever it's going on. So those are what we would need to add in an explanation of what's going on. All right, so that's part A. Part B says, use the data in the table to find W of -1 of 257. Using appropriate units, explain the meaning of your answer. Now, this is that notation that is really, to me, is really troubling that they use that, because x to the -1 we know is 1 over x. That is not what they're meaning here. They're meaning inverse, the inverse. So let's remember what the scenario is with inverses. So with an inverse, that's where we switch the x's and the y's. Or we switch the x's and the y's. With reciprocals is where we, flip the fraction. This is actually an inverse. So this used to be a y value in the regular function. It used to be a y value. Now it's an x value. So we would say W -1 of 257 equals, so we're looking here. It was a y value, now it's an x value, equals 12 hours. So we're going to use the same format to explain as we did up here. We're going to talk about the independent variable. So when 257 gallons of water, when 257 gallons of water, so I just indicated the independent variable of water was in the tank. It was at the 12th hour. And Probably most of you are better English than I am. You could probably make it sound prettier than that. The important thing is that we have the information there. Did we describe the independent variable and name the units? Did we describe the dependent variable, water, and name the units? And did we describe the scenario? Is really what it is. All right. So part C is tells us to use the data in the table to find an approximation for W prime of 15. In other words, the first derivative at 15. Show the computations, use appropriate units, explain the meaning. Well, we have a position function. We really don't have any way to find the derivative. We don't have an equation. What we have to do in a scenario like this is fall back on our last resort. And really our last resort to approximate a derivative would be to use the slope of the secant, the average rate of change. That's kind of like our last resort. That's really all we have to work with. We certainly wouldn't do that at the first. That wouldn't be our first choice. If we had an equation, we'd find a derivative. I mean, we'd do other things. If we had a graph, we'd do something with a graph. But we don't have any of that, so we're going to have to resort to finding the slope of the secant for the approximation. So we would say W prime of 15 is approximately, and notice I don't even have another thing that's a little troubling is the 15 isn't even exactly in the middle. You know, we're going to have to use this data to calculate. 15 is closer over here, but it's just all we have. It's all we have to use, so that's what we're going to use. So we would do 294 minus 257 over 16 minus 12, and that would give us 9.25 gallons per hour. All right, so now for the explanation. We would say at hour 15, the water is flowing into the tank. Into the tank at approximately 9.25 gallons per hour. Okay, so again, let's make sure we have all the information. We have our independent variable, we have our dependent variable, and we've named the scenario, what it is that's happening. Okay, we okay so far? Okay, so we're finding average rate of change. It's the rate of change, not really the speed. So the average rate of change, it could be speed, it could be water flowing. I mean, it could be any number of things. It's just an average rate of change. And so that's what we're finding. We're finding the average rate that the water was flowing into the tank is what we're finding. Good question. Now, what they won't always tell you to explain, but so here's the quandary. They're not going to always tell you to explain, but they're going to want you to explain. Sometimes they assign points to it, and sometimes they don't. So it's kind of a gamble if you don't write an explanation. It's kind of a gamble on whether they're going to award a point to that or not. So it just takes a few seconds. I would recommend you just go ahead and write the explanation. Just go ahead and write it. All right. So we good so far? All right, then let's go to the next page. All right, so same scenario. We have a few different questions. So part D is asking us, again, same prompts. We're using the same data. Use the data in the table to find the average rate of change of W of t over a time period, 4 to 20 hours. Show the computations that lead to your answer. All right, so we're looking for 4 to 20 hours. So we're looking here to here. So we know how to do slope of the secant, average rate of change. So we would do that. Part D. So average rate of change is going to be 327 minus 184 over 20 minus 4. And that is 8.9375. And that's gallons per hour. Now let's talk about our accuracy. In pre-cal, what we were working on is getting you used to the thousandths place, because that's what these guys want. They want you to be accurate to the thousandths place unless they say otherwise. It's that whole reading direction thing. Maybe they might say to the nearest whole number, but if they don't say anything, they mean to the thousandths. And what they will do is they will allow for rounding or truncating. So if we rounded, it would be 0.938. That's fine. If we truncated, we would just chop that off. It'd be 0.937. Either of those are acceptable. But they are very picky about that. If this was an answer on the AP test and you put 8.932, you wouldn't get the point for it. So you need to be very cautious. Don't round intermediate rounding. Wait until the end to round, because they want it accurate to the thousandth. Now, if you wanted to put more decimal places in the thousandth, they're fine with that, unless they say, round to the hundredth or something. They're fine with that. So you can put 4 decimal places if you don't want to mess with rounding or truncating. But our standard is 3 decimal places, or to the thousandth. Okay, we okay with that? All right, let's take a look at part E. It says for 0 to 24, there must be a time t when the tank contains 265 gallons of water. What do you think? Does there have to be a time between 0 and 24 where the tank has to have 265? There has to be, right? And so that's a yes. And why? Yep, by the IVT. Now, this is an example of how you might see the IVT shown in a free response problem, just like this. And so what we would want to do is use the IVT. Let's do the 3 steps. It'll take us 30 seconds. So step 1, what do we know is about the IVT? What do we say? And actually, on the test, you did a great job on this. What is step 1 for the IVT? It's continuous. So we would say, step 1, the water flowing into the tank is continuous. Now, just like when we are judging continuity of, say, a polynomial, we would just say by observation. That's kind of what we're doing, by observation. We also know that it was differentiable, which means it's continuous. So the tank is continuous. And then part 2, what's the second part of the IVT? Yeah, the y values have to be, the endpoints have to be different. The y values of the endpoints have to be different. So see, w of, what are we at, 0 does not equal w of 24. Good. Step 3. The between, right? The y value, so 265, is that what? Yeah, 265 is between w of 0 and w of 24. Or you could write out the y values if you wanted to, or put it in an inequality. Some of you put it in inequality, and that's fine. So since it's a scenario, they would want us to put more in than just an abstract function. They would want us to say what the topic was, water flowing or whatever it happens to be, air blowing up a balloon or whatever. It would want us to say what it was. All right, so part E. Part F is asking us it gives us a model for the amount of water in the tank, that A of T, where A of T is measured in gallons and T is measured in hours. They want us to find A prime of 15. So on this one, what we're going to do is we're going to use our calculator to do that, and that's where the calculator comes in. I'm going to go over finding the derivatives on a calculator. So let me erase just this little part right here, and then we will go to our calculator. Alright, if you have your calculator with you, it'd be great if you got that out. And I'll talk to you about this particular calculator. Okay, so let's talk about calculator usage on the AP test. You can use an 89 on the AP test, you just can't use one in here, so I'm really not going to talk about how to do that on an 89. I'm going to talk about the 84. So if you have an 84, if you have the new operating system, that would be great. The way that you could tell is by going Math 8. If you do Math 8 and you get what I have here, then you have the old operating system. If you do Math 8 and you get this, then you have the new operating system. Okay, if you have an 84 with the old operating system, my advice is to get the new operating system. You can get it free. It's a free download from TI. You just need a cable link. If you need help with it, I can help you. If you have an 83, there isn't a new operating system for that, and you would have to input it like this. Now, the reason I'm talking to you about it now, it's September. In May, you're going to be using your calculator on the test, and you will be able to work faster if you have the new operating system. It's just easier to input. It's faster. So if you don't have it, I would suggest you looking into ways to get the new operating system. You know, I have a cable link. If you want to, we can work on it, whatever you need to do. If you have the old operating system, you need to get the new. So I have the old operating system on this one, so we're just going to walk through the old operating system, what you would do. I prefer doing derivatives and integrals on a blank screen versus in the graphing screen. You can do it in the graphing screen if you want. That's fine. And so what you would do is on the old operating system, you would put in your equation here first. And so we need to be cautious. And there we go. So the fractions need to be entered in parentheses. So it's what, 1 over 225. That needs to be in parentheses, and then I need to open another parentheses to put the rest of the equation in. So it's negative. You don't have to put a t in there. The calculator doesn't care if it's a t or an x. Cubed. So negative t cubed plus 30t squared plus 1800 t plus 33 750. Okay, and I'm closing that equation. 33,750. All right. Then on the old operating system, you'd put a comma, and you'd type an X. Then you put a comma, and you put a 15. Now let's talk about the new operating system. What you would do is you would put an X right here. You would type in the equation right here. And when you put an X in here, automatically an X pops up here. You don't have to put anything there. And then you would put the 15 here. If you have the new operating system, that's what you would do. And then you just hit enter. And if you input it correctly, you should get a 9. If you didn't input it correctly, you're going to get a different number. And you need to look to see whether you messed up parentheses or something. But you can see by this, remembering all the, the comma, the X, the comma, it takes longer than just subbing into this pre-made formula. This right here? This guy, yeah, the equation. Yep, equation in there. That's right. All right, and so that tells us that, how are we on the calculator? Is everybody okay? Okay. All right, so what that does is, that is part F. So on part F, we know that a prime of 15, in other words, the first derivative at 15 is 9 gallons per hour. And then part G, this says use the model given in part F, find the average rate of change over the time period 4 to 20 hours. All right, so what does that mean? That means we know average rate of change means slope of the secant. So it wants us to use this formula. So it would be A of 20 minus A of 4 over 20 minus 4. Now how am I going to get A of 20? How am I going to do that? Ideas? Just plug a 20 in there, right? You with me? Are we sleepy today? Put a 20 here. Get the number. Put a 4 there. Now, I would probably put this in the y equals and just do, second calc or value or something, or go to my table. I would probably do that. It would be faster than, well, who knows? I don't know which one would be faster because we have that copy thing now. So, at any rate, you need to plug a 20 in there, get that value, plug a 4 in there, get that value, do the calculations, and you'll get 8.9955 gallons per hour. Okay? And that pretty much takes care of this lesson. Okay, any questions?